Okay, this video is on equivalent ratios. So whenever you think of ratios, think about what you also already know about fractions, because ratios are just another way of writing a fraction. So if I said to you, take, say, the fraction 5/12 and write an equivalent fraction, you could multiply, say, the numerator by any number. Let's pick a number, say 4. And whatever you do to the numerator, you also need to do to the denominator. Otherwise, you're changing the actual fraction. So that would give me 20 over 48. And what that is that's an equivalent fraction. So 20 over 48 is equal to, that's what equivalent means, is equal to 5/12. They're equivalent to one another. So we're going to be doing exactly that same idea with ratios, which is if we are creating an equivalent ratio, whatever we are multiplying one part of the ratio by will make the same change to the other side of the ratio. So here's an example of two ratios that are equivalent, but there's a missing part. So we have to find out exactly what number to put there. And the easiest way to tackle these is, well, link the parts that you already know. So I know the first number in both these ratios, and so I can link those. And I know that to get from 3 to 21, well, I have multiplied by 7, just like when we multiply to get an equivalent fraction. So that means if I've multiplied by 7 to join these two front numbers together, then the second numbers in my ratio will be joined by exactly the same operation. So I will also multiply by 7, and that gives me 49. So that means that the ratio 3 to 7 is equivalent to 21 to 49. And the way to check that would be to get that ratio, this second ratio, and let's reduce it. The highest common factor of 21 and 49 is 7. So if I divide by 7, I will get 3, because 21 divided by 7 is 3, and 49 divided by 7 is 7, so I get 3 to 7. So I can see that it actually works. Right, let's try this process again with the second example, and we're going to link the numbers that we have in both ratios. And in this example, we have the second number in both my ratios. So there's that second number, and I can see that to go from 12 to 60, I'm going to times by 5. Now, actually, let me change that. What I want you to always make sure you do is when you link your numbers together, you must go in the direction of the ratio with the missing part. So in this example, the ratio with the missing number is here. So when I draw my arrow, it's actually going to be in this direction. And same with this other arrow that I will eventually draw. So, and the reason why is that helps you to think about the right operation. So to go from the number 60 to 12, this time around I'm getting smaller. What I need to do is I need to divide by 5. And if I'm dividing by 5 that way, then to get the first number in my first ratio, I'll use that exact same operation. So 10 divided by 5 will give me 2, and that gives me my missing number in the ratio. Once again, you can always check this. So 2 to 12, I know that that reduces to 1 to 6. So hopefully your number skills with ratios are getting better. And if you think about 10 to 60, that is also the ratio 1 to 6, because my second number is 6 times as big as my first number, or you could just divide both numbers by 10. So I can see that my answers are actually correct. So really you should be always in the back of your mind doing a bit of a mental check. So same process, but a bit faster this time. We'll join the parts that we have. So we have the second number in both ratios, but I will draw my arrow towards the unknown ratio. So that's in the direction of the ratio with the missing part. And that means I'll draw my other arrow in exactly the same way. To go from 6 to 24, we times by 4. And that means I'm going to do the exact same thing with my other direction. So that means 4 multiplied by 4 gives me 16. So that helps me to find that missing number. The only way to make this harder would be where it's hard to find it, to work out how to link the parts. So for example, in this case, we've got 18 and 30, and I can't think off the top of my head of a number that I can multiply 18 by to get 30. So what you can do in this example is you could reduce your ratio. So if I take 15 and 18, the highest common factor is 3. And that would give me a ratio of 5 to 6. So now I'm trying to work out a missing number with the ratio 5 to 6 and some number which I don't know to 30. And so I'm going to do what I did before, which is link the numbers that I know, And to go from 6 to 30, I can times by 5. So we're going to do exactly the same thing here. We're going to multiply by 5, and 5 5s will give me 25. Same thing here. I don't really know what number to multiply 35 to get 49. So what I could do is I could reduce the ratio, and I can see that 5 goes into both 35 and 25. And that'll give me a ratio of 5 to 7. So now I'm going to try and find an equivalent ratio, or find the number really that goes in this location, such that the ratio 5 to 7 and this number to 49 are equivalent. Link the parts that I know, draw the direction of the arrow towards your unknown, and I can see that to go from 7 to 49 we times by 7. So we'll do the same over here. And 5 7s gives me 35. So that's all you're doing. You're finding this missing number so that the two ratios are indeed equivalent. Here's some for you to try, and then I will display the solutions in a sec. So what you can do is pause the video, work your way through these questions, check that you get them right once I put the solutions up, and I want you to look, so pause the video now, do the questions. When you do see the solutions, you'll see that I've written in the operation, times by, or divide by, divide by. Alright, have some fun working, pause the video, and here are the answers.